Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on solving linear equations. So we're going to look at solving equations like this. 3 outside of x plus 5 equals 24. So by solving, we mean we're going to find a value that we can substitute for x, or whatever pronumeral, to make this statement true. What number can I put here that will make this a true statement? So in order to find the solution, we undo what's been done to x. Now, sometimes we want to simplify the equation first. So here I'm going to make it a little simpler by expanding the brackets. Remember, I go 3 times x and then 3 times 5. So now I'm ready to solve. I'm going to undo everything that's been done to x. So x has been multiplied by 3, that's how I got the 3x, and then I've added 15 to get 24. When I'm solving, I undo things in the opposite order to BODMAS or BIDMAS. So we did the multiplication first, then we added. So I undo in the opposite order. I'm going to undo the adding 15 first, then undo the timesing by 3. So to undo adding 15, I'm going to subtract 15 from both sides. So 15 minus 15, they just cancel out. So then left-hand side's just 3x, 24 minus 15 on the right-hand side is 9. Now I'm going to undo timesing by 3 by dividing each side by 3, and my solution is x equals 3. So that's the solution, because if I substitute x for 3 here, I get 3 times 8, 3 plus 5 is 8, 3 times 8 equals 24. That is a true statement. So let's look at an example like this, because a lot of people get tripped up on something like this. So where they get tripped up is with this 16. This is a positive 16, subtract 2x equals 40, right? So to get rid of the 16 from the left-hand side, to undo this 16, I actually need to subtract 16 from both sides, because 16 minus 16 is 0. I get rid of it. So the next line is minus 2x is 40 minus 16 is equal to 24. So this isn't 2x, this is minus 2x. X has been times by minus 2. So now if I want to undo timesing by minus 2, I need to divide by negative 2, not positive 2. So 2x divided by minus 2. Well, the times minus 2 and divide minus 2 cancel out. So I'm just left with x equals 24 divided minus 2 is negative 12. Once again, this is the solution, because if I change x to minus 12 here, I get a true statement. I get 16 minus 2 times minus 12 equals 40. That is a true statement. If you put that on your calculator, you will get 40. Now let's look quickly at examples where the pronumeral is on both sides of the equation. So when the pronumeral is on both sides of the equation, you may need to simplify the equation first, but then what you always need to do is subtract the variable or pronumeral, the letter, with the lowest coefficient. Let's look at what I mean by that. So let's solve the equation 18 plus 2x equals 6 plus 5x. So this has x, which is the pronumeral or the variable, on both sides of this equal sign, on the left-hand side and on the right-hand side. So I can't just jump straight into solving. Before I undo what's been done to x, I need to subtract the variable with the lowest coefficient. So that's this one here. What I need to do is subtract 2x from both sides. The reason I'm doing this, I only know how to solve linear equations when the x, or whatever letter it is in one spot. Here it's in 2 spots. So by subtracting 2x from both sides, we'll end up with x in only one spot. So 2x minus 2x, they just cancel out. So I'm left with 18 on the left-hand side. Now on the right-hand side, remember, we have to employ what we know about like terms. So 2x and 6 are not like terms. So the 6 is going to stay as it is. But 5x and 2x are like terms. 5x minus 2x is 3x. Now you can see I have an equation in which the variable or pronumeral is on only one side. So I can just use exactly what I did, the steps on the previous slide. So I'm going to first subtract 6 from both sides, and I get 12 equals 3x. And then I'm going to undo timesing by 3 by dividing by 3, and I get x equals 4. So this is the solution, because if I substitute x for 4 here, I would get 18 plus 8, which is 26 on the left-hand side. On the right-hand side, I'd get 6 plus 20, which is 26. If I substitute this x for 4 and this x for 4, I get a true statement. All right, let's look at one that's a little harder. So we'll do this equation in blue. Once again, x, the pronumeral, is on both sides of the equation. I want to solve it. I want to find what value I can substitute here and here that will make this a true statement. So here, I'm going to first simplify the equation before subtracting the x's. So if you have a fraction like this, they're not easy to deal with. But what I can do to get rid of the fraction is times this side by 4. Now, what you do to the left-hand side, you must also do to the right-hand side. So I'm going to times each side of the equation by 4. So on the left-hand side, divide 4 and times 4 cancel each other out. So I'm just left with this. On the right-hand side, if I'm timesing this by 4, I have to times everything by 4. So I have to times the 2x by 4 and the 3 by 4. So now this equation looks like the one I did over there. What I'm going to do is subtract the x with the lowest coefficient. Now, the x with the lowest coefficient here is this one. Its coefficient is not 3, it's negative 3. So I can't subtract 3x. I'm going to subtract negative 3x from both sides. Remember, negative negative makes a plus. So what I'm actually going to do is add 3x to both sides. Because if I add 3x to both sides, it'll get rid of it on the left-hand side. I'm just left with 12 equals 11x plus 12. Now that's what I wanted. I want to get a situation where I have x on only one side of the equation. So now I can just subtract 12 from both sides and solve this like we've done a million others. But I actually get 0 equals 11x. So don't be fooled here. X is not 11 divided by 0. If you put that in your calculator, you'll get an error. It's 0 divided by 11. We're dividing each side by 11, so x is actually 0. So this is the solution, because if I substitute x for 0 here and x for 0 here, this side equals 3, this side equals 3. All right, let's look at a couple of worded problems. So we're now going to solve 2 worded problems using equations. So whenever you have a worded problem, follow these steps. The first step is define your variable. So define the variable means let x equal the thing you're trying to find. So in this question here, it says, in 5 years' time, I'll be 3 times as old as I was 9 years ago. What is my current age? I'm being asked to find my current age. So I'm going to let x be my current age. So after we've defined the variable, the second thing we want to do is form an equation. What that means is we want to take all of that worded information and rewrite it using only mathematical symbols. So here, in 5 years' time, so if I'm x now, if that's my age, in 5 years' time, I will be x plus 5. So x plus 5 is the same as 3 times my age 9 years ago. So if my age now is x, my age 9 years ago is x minus 9. If I'm 25 now, I would be 25 minus 9, 16, 9 years ago. So this is the equation. I've just rewritten all of this information just using x's and numbers and all that. My age in 5 years equals 3 times my age 9 years ago. So the third step here is just to solve. Because once you've got the equation, that's the hard part. Now we just need to employ what we have put in place in the previous few slides. So this equation here is another example of where x is on both sides. So first I'm going to simplify this equation by expanding the brackets. So 3 times x and 3 times minus 9. And remember, what I need to do is subtract the x with the lowest coefficient. So this is the one with the lowest coefficient. Its coefficient's 1. Remember, I do this so that I can end up with x in only one spot. So the left-hand side is just 5. The right-hand side, 3x minus x is 2x. And of course, minus 27 and x are not like terms. So I just leave the minus 27 alone. So now what I'm going to do is add 27 to both sides and divide by 2. So I get x equals 16. So what you're supposed to do when solving a worded equation is just give a worded answer. So I found x equals 16. X is my current age, so I just write a sentence saying that. Okay, and after I've written this sentence in red, I am done. Let's look at the next question. So at a canteen, donuts cost $1 more than cans of Coke. I buy 2 donuts, 3 cans of Coke, and pay $9. How much is each item? So don't deviate from the process I just explained to you. We're going to follow these 3 steps once again. So the first step is to define our variable. So what I want to do is let x equal something. Now here, I'm actually finding 2 things. I want to find the cost of a donut and the cost of a Coke. So I'm just going to let x equal one of those things. Usually it's easiest if we let it be the smaller quantity, but it doesn't matter. So I'm going to let x equal the cost of the Coke. Now, if x is the cost of the Coke, I need to write the cost of a donut in terms of x. I don't want to use a different letter for the cost of a donut because I don't know how to solve linear equations where there's more than one letter. All the linear equations we've solved have been like this, where there's only one letter. In this case, the only letter was x. So I'm not going to let y be the cost of a donut. Because I know that a donut is $1 more than a can of Coke, if x is the can of Coke, x plus 1, cost of Coke plus $1 is the cost of a donut. So I want to do that so that when I make my equation, it only has x's in it. So now let's put this into an equation. Well, that's actually pretty simple. 2 donuts plus 3 cans of Coke is equal to $9. So that is the hard part, doing all this and coming up with the equation. Now I just need to solve it as normal. So I'm going to first expand the brackets. And now I need to collect like terms. So 2x plus 3x is just 5x. So I get 5x plus 2 is equal 9. Subtract 2 from both sides, and then if you divide by 5, you get x equals 1.4. The answer doesn't have to be a whole number. So remember, x is the cost of a Coke. So I've just figured out that each Coke costs $1.40, which means each donut costs $2.40. And then once again, I write a worded answer here saying exactly what I just said. Alright, sorry for the long video. Thanks for watching. This has been the luckiest maths teacher in the world. Have a great day.